This is for help on worksheet 4.3a, just in case you need it. And we are working on proving two triangles are congruent using our angle included side angle postulate. So you are searching in these first four for the pair of triangles that have two pairs of marked angles congruent and the side between them marked congruent. So let's go look at number 4. I can see that I've got a single arc and a single arc and a single arc. All of these have a congruent angle. They all have a congruent double marked angle at L, C, and D. But the side on this one, on DF, isn't the one smashed between the two angles. So our answer for naming two triangles that are congruent for number 4 would be triangle A, B, C, and then match its corresponding parts is congruent to triangle J, K, L. This proof was done in the video notes in class, so let's talk about a couple of these other proofs. So our goal is to get the triangles congruent by angle, side, angle. So let's take a look at number 6. We've got one pair of angles marked and one pair of sides marked. So we need to get the angle on the other side of the side. So we can go angle, side, angle. In here at where this X is made, and that's a vertical angle theorem. So one of the reasons you're going to have to add with your brain is that angle JKL is congruent to angle PLM by the vertical angle theorem. On number 7, that one's a little tricky. So what we have here is a pair of parallel runners. Usually that means alternate interior, but for this one at angle A and in here at angle B, DBC, those are called corresponding angles. That would be the same. So you're going to have to state that angle A is congruent to angle DBC by cap. Then you'll have angle, side, angle. On number 8, we have T being the midpoint, which means that it chops QS into two equal pieces. So you should put a single dash here on QT and a single dash here on ST. Now we have angle, side. Can we get the included angle the same? And again, we have that vertical angle theorem. So this one's going to have the given and then 2 steps. One, definition of midpoint for getting QT the same as ST, and another for the vertical angle theorem in there at QTP and STR. All of these end with what you're supposed to prove, and our reason today is angle, side, angle. On number 9, we have these parallel runners. And again, that's a trigger for alternate interior. So I would put double arcs in here at FGJ and double arcs in here at HJG. They're congruent, which will be one of the statements you make, by the alternate interior angle theorem. The side smash between the given ones and the ones that you should state are the same by the alternate interior angle theorem is congruent to itself by the reflexive property. Number 11 was done in your notes in class. Number 10 is going to have some definition of bisect to get this angle up here at D congruent to this other one up here at D. We're also going to have a little reflexive on DH, so that'll have the given and then 2 statements with reasons. One reason will be definition of bisect for getting a pair of angles the same, and the other one will be reflexive for getting that side the same. Down here, when we're listing corresponding parts, remember angle T is congruent to angle L, angle I is congruent to angle O because they're both the second ones, angle C is congruent to angle K because they're both the last ones. For the sides, you grab 2 letters on this one. Side, TI, with the segment over it, is congruent to side, LO, first 2 letters. Side, IC, is congruent to side, OK, with the second letters. And then you can do the third one. And remember for number 15, for doing a midpoint, we have to get in the middle of the x's or average them. So you do -1 plus 5, which is 4, and then you divide it by 2. To get in the middle of the y's, you do 2 plus 6, and then divide that by 2. So that's some help with, or a lot of help with worksheet 4.3a from